You've already seen a number of layout panes used in Java FX, in particular the stack pane, the H-box. Those both appeared in previous demos that we looked at. Both those kinds of panes and all the other panes that we'll be looking at in this next section are classes that extend from the pane class, which is a base class for layout panes. It is in this base class that the getChildren method is defined that we've seen us use now in both HBox and in StackPane. Although we saw HBox before, we'll be reviewing it along with VBox towards the end of this material. On the other hand, StackPane we won't be looking at explicitly because we have looked at it before. However, we'll review it before going on. So just to remind you how stack pane worked is as you add children to a stack pane, those nodes are placed one on top of each other in the center of the pane. And you'll recall that the last time we saw that was in the context of putting two children in a stack pane. One was a circle and the other was a label. And so in the end we saw the label over top of the circle. We'll now look at the rest of the panes that you see here in the order that they occur. So we'll look at the FlowPane next, and the GridPane, then the BorderPane, and then the H-box and the V-box to finish this part of the lecture off. The FlowPane can work two different ways, either horizontally or vertically. We're going to start by talking about the horizontal one because it's easier to describe in terms of comparing it to how you read things. So when you read words on a page, you start in the top left corner and you read the words left to right until you run out of words because you get to the end of the line, in which case you move down to the next line and again begin reading left to right, and you repeat this process until you've covered all the rows on the page. This is the way that a flow pane works when it's set up horizontally, which is the default, meaning from left to right. As you add children to a flow pane, the first child will emerge at the far left-hand side of the first row. The next child will appear to the right of that, third child to the right of that, and so on until you fill up the entire row. The next child that you add will appear as the first item in the following row, and so on and so forth. What I've just described would be the horizontal orientation for a flow pane. You can alternatively set vertical orientation, and when you do so, you'll do so during the construction process by passing an argument orientation.vertical. Although you can say orientation.horizontal and put that argument in there, leaving it out will amount to the same thing since that is the default, and that's the behavior that I just described. If you don't want this default behavior and you want vertical orientation, then first of all you'll have to pass that argument in as the argument for the constructor. You have to say orientation.vertical. And when you do this, what will happen is instead of it being the same order that you would read words on a page, it instead would go down the columns. That means that the first child you add to the flow pane when you set it for vertical orientation will still go in the top left corner just like before, but now the second child will go underneath it and the third child under that, and so on and so forth until the entire column fills up, and then the next child will move into the top position in the column to the right of the first column and begin filling down from there with the next child and the next child and so on. You can also give an argument into the constructor to specify the gap that you want between nodes specified in pixels. In other words, the spacing between children. Here's the UML diagram for the flow pane. What we'll point out here for you right now is the existence of the various constructors. So you can call it with a no-arg constructor, in which case you get a default flow pane. You can call it with two doubles for arguments, in which case the first is interpreted as a horizontal gap and the second as a vertical gap between the items. If you call it with a single argument, that argument is understood to be an orientation, and that would be either the constant orientation.vertical or orientation.horizontal as we saw before. And finally, if you pass the constructor a total of three arguments, then the first one will be the orientation, the next the horizontal gap, and the last with a vertical gap. The demonstration code for the flow pane is relatively simple, and it probably doesn't make sense to spend the time and effort to go out to the Eclipse IDE to try it, we'll just go through the slide and discuss what it does. You can see we've defined in the third line a FlowPane called pane. We set some padding for it. We've talked about that before. This would be the padding with 4 arguments, 11, 12, 13, and 14, where in order that would represent the padding over, to the right, under, and to the left of the pane. So this represents the padding around the entire FlowPane. We then set the horizontal gap for 5 and the vertical gap for 5. Since we haven't set the orientation, it's going to be the default of horizontal orientation. And the middle block of code that you see there is where we place the nodes into the pane. What the author does in the code here is he actually sets 3 different nodes into the FlowPane, and then he creates a 4th one which he subsequently sets into the FlowPane separately along with 2 more. So there are a total of 6 nodes that are being inserted into the FlowPane altogether. The first 3 of these nodes are anonymous, they don't have names. So let's take a look at where this happens. We have pane.getChildren.addAll. So whereas the add method adds a single child to a pane, addAll allows you to, in one foul swoop, install a number of nodes into the pane. So in particular, we're adding 3 nodes at once, all anonymous. So the first we say new label first name. We didn't give the object a name, but it nevertheless exists and is now an anonymous object that's been inserted into the pane. And next, new text field, similar story there. And finally, new label, quote, mi quote. The next node is a text field which the author calls TFMI, text field middle initial. He creates it as new text field, and the reason that this one was not anonymous is that he wants to use the set pref column count in conjunction with it, and it has to have a name for him to be able to do that. So in that next line of code you see TFMI dot set pref column count 1. What this does is it sets the maximum number of characters the text field can display at one time. Having done that, he then inserts it as a child into the pane at the next position, along with 2 new anonymous children, new label last name, and another new text field. So in order, the children that have been put into this FlowPane are then a label, a text field, another label, a text field, another label, and one final text field. At the bottom of the slide, we set a scene of size 300 by 100 and drop our pane, our FlowPane, into it. The title for the stage is Show FlowPane. We then drop the scene into the stage and we show the stage. Now let's take a look at the top right corner where we see the result of doing all of this. The order that the nodes were dropped into the FlowPane was, first of all, the label that was labeled first name, and then a text field, and then the label that was middle initial, and then another short small text field that we set to pref column count as 1, and then a label last name, and then one more text field. If you look at what you see there, you can see that in fact that is the order left to right and top to bottom that those nodes appeared in the window. When we created the FlowPane a moment ago, we put some padding around it, and you recall seeing insets 11, 12, 13, 14. This provides padding in order on the top side, right side, bottom side, and left side. The padding is specified in pixels. So we have 11 pixels on the top, 12 pixels to the right of the FlowPane, 13 underneath it, and 14 to the left of the FlowPane. In our demo, we also specified H-gap and V-gap properties that give the horizontal and vertical gap between items in the FlowPane. Although the figure shown here doesn't coincide with the example that we were looking at the code for just a while ago, it does show you what the definition of H-gap and V-gap is. So between using inserts for padding and H-gap and V-gap for spacing between items, we have a certain amount of control over where these items are going to appear as we use a FlowPane. The next kind of pane we're going to look at is the GridPane. In a grid pane, all the nodes are arranged in rows and columns. The indices of the rows and columns start at 0. The total number of rows and columns present in the grid pane will depend on the largest indexes that we use for rows and columns. A column and row index will be used, that's 2 indices, for every item that we put into the grid pane. Also, it's not necessary to give row and column indices for every location in the pane. So in other words, we don't have to put something in every single cell. We can leave as many cells blank as we wish. The number of rows that are present in the grid pane will be determined by the largest row index that appears in any of the elements that we put into the grid pane. Similarly, the number of columns that will appear in the grid pane will depend on the largest column index that we've used. In each case, that value will be one greater than the largest index for the row and the column. So the simplest example that we could use is say that the biggest column index that we use is 1 and the biggest row index that we use is 1. This would mean that there would be 2 columns total and 2 rows total. From the UML diagram that you see here, you can see once again that there's an H gap and a V gap. This will be used to specify the amount of gap vertically and horizontally between columns and rows. Although in most of the examples we look at we're just going to be adding children to grid panes, it's possible to add entire rows and columns, as you can see by looking through the UML diagram. Once again, the example code for our grid pane is relatively simple, so it's not really necessary for us to go out into the Eclipse IDE and try it out. We'll just talk the code through on the slide. The third line from the top is where we create our grid pane called pane. In the next line of code, we set the alignment to the center of each cell for items that we put in cells. We'll see an example later where we override this. The next line of code specifies padding on top, right, bottom, and left all the way around our pane. The next 2 lines set the horizontal and vertical gap, which we've talked about already. The middle section of code is where we actually enter or put items into the grid pane. Now before looking at the details in the code, have a look up in the right hand corner where the actual output is shown. You can see that there's a total of 8 cells that are going to be present in this grid pane, 4 rows and 2 columns. Bearing that in mind, let's look at the code now. The first thing you should do is identify where the indices are in each case. We're doing a pane.add, and in every case the last 2 arguments of the add method are always going to be the indices. The first index is the column index, it's like the X value, and the second index is the row index, like the Y value. So you can think of X as going from left to right and Y as going up and down. So keeping that in mind, have a look at all the indices that you see present there. First of all, note there should be a total of 7 pairs of indices because there's 7 items in the grid pane. So reading from top to bottom, we have 00, 10, 01, 11, 02, 12, and finally 13. The biggest column index we encountered was a 1. Therefore, we know there are 1 plus 1, or 2 columns total in the grid pane. The biggest row index we encountered was 3. Therefore, we know that there are 3 plus 1, or 4 rows in total in the grid pane. With only 7 items added to the pane, we know there's going to have to be at least one empty cell somewhere. If you look through all the indices, you'll notice that the pair 03 never appears. That would be the first column in the 4th row. And if you look in that position, you'll see there's nothing there. So this shows how we don't have to fill every cell in a grid pane. In your study time, you can go through those different pairs of indices that you see and the particular items that are being added to the pane to justify why they appear where they appear in that pane. We won't take the time to do that right now. What I will point out though is the last line in that middle block of code overrides the centering. We say GridPane.set horizontal alignment button add comma hpos.right, and you'll notice that that node at position 1, 3, which is the add name button, it's not centered within that column, but it's pushed way off to the right hand side because of what we've done in that line of code. And of course on the bottom section of the code right near the bottom of the slide is where we do the usual things to actually set the pane in the scene and the scene in the stage and finally show the stage. We now move on to the border pane. The border pane turns out to be a pretty popular choice of panes because of its nature. It has 5 regions associated with it: the top, bottom, left, right, and the center. The top and bottom sections occupy the entire top and bottom section, as the name would imply. The left, right, and center parts, however, occupy the area between the top and bottom. In other words, the pane is divided in such a way that we effectively have 3 rows. The entire top row is what we call the top region, the entire bottom row is what we call the bottom region, and the middle row contains 3 pieces, the left, right, and center, as though it were 3 columns appearing in that particular row. You can put items in each of these areas by using set top for the top area, set bottom for the bottom area, set left, set right, and set center for the left, right, and center areas. As an argument for each of these methods, you simply specify the node that you wish to put in that area. One interesting thing about these regions is they're variable in size, and they only have size when you actually put a node in them. So in other words, if we don't put anything in the top node, it will shrink to height 0 and won't even be visible. And in fact, the left, right, and center portions will actually fill up to the top as a result. Similarly, if we choose not to put any node in the left section, it will collapse to width of 0, and the center portion will move right over to the far left border as a result. You may need to play around with this a little bit to appreciate what I'm saying here. I'll also try to explain it further by indicating what would happen if you leave the bottom node empty. So let's say you don't put any nodes in the bottom section. Then it will shrink to height 0, and the left, right, and center portions will go all the way down to the bottom. Let's do one last example. Suppose that you don't have any nodes in the top or the bottom, but you do put items in the left, right, and center areas. Then what will happen is the left section will occupy right from the bottom of the pane to the top, and from the left side to wherever the center starts. The center will also go full top to full bottom and occupy the center region, and then the right section will go full top all the way to full bottom and occupy the right area. The reason I'm mentioning this and emphasizing it is in the example we look at, we put nodes in every single region, so you can't really appreciate from the demo which follows what would happen if we elected to leave a node out of a particular region.